All right, so question 1.2 of the group work questions is we're asked to multiply by 7 as fast as humanly possible. So adding in a loop, that's far too slow. And we know that logical shifts can multiply by powers of 2, but 7 is not a power of 2. So before we even start talking about the solution, we should think about how we can even possibly do this. So one way to do this is you could decompose 7 as sums of powers of 2. So for example, 7x is equal to 4x plus 2x plus x. And I know how to multiply by 4. Multiplying by 4 is just a bit shift by 2. So this special symbol here, the two little arrows, just means like a logical left shift by 2 plus shift by 1 plus x. And so if we implemented this, this would be roughly 5 or 6 or so instructions. But we can actually do a little bit better. Because you can write 7x as 8x subtract x. And then multiplying by 8 is a bit shift by 3. So here, this is even faster. It's a single logical shift and a single subtraction. So let's implement that. We'll assume the result is sitting in R0. So what I will do is I will shift R0 by 13. By 3, sorry. So left shift by 3, which is the same as multiplying by 8. And I can't store it back in R0 or I'll overwrite the original result because I need the original result to subtract off afterwards, right? And the question says I should store the results in R1, so I will do that. And then I'll subtract the original result back off again. All right. So let's have a look. 7 times x is 8 lots of x subtract x. Left shift by 3, subtract 1. So we're left shifting by 3, store the result in R1. And then I subtract the original result from R1 and put it back in R1. Okay, so let's give this a go. So we'll build it. And it's upset because I didn't comment out the last part of the question. Let's try it again. All right, there we go, it's happy. Let's turn on the debugger and let's see if this code works. So pretty short, right? Only 2 instructions, but we'll first check that it works. So we'll skip ahead to the main. All right, so put a 13 in R0, left shift by 8. So we multiply 13 by 8 to get 104, and then subtract 13 to get 91. And you can verify for yourself that 13 times 7 is indeed 91. So 2 instructions. Can we do better? Well, we're gonna have to look at the cheat sheet, right? So if we have a look at the cheat sheet, we can see a lot of these instructions have this additional optional shift. So sometimes you can do an add and a shift, or a multiply and a shift, an add and a shift, or a subtract and a shift, or like a logical operation and a shift, all in a single instruction. So we're looking for an instruction that shifts something and then subtracts from the result. So if we have a look here at sub, what sub does is it takes a number and subtracts something shifted. Well, that's not what we want. We want to shift and then subtract. So we have a look at this command here, RSB, which is reverse subtraction. So what is it doing? You give it a register RN and a register RM. It shifts the second register and then subtracts from it the first register and stores it in the destination. And that's what we want. So we can use this command. So we can replace these 2 instructions here with one single instruction. R1, R0, R0, and then how does the shifting work? So you have to put in something of the form shift. If we have a look at the bottom of the cheat sheet, we've got this part here, which tells us how to shift. We want a logical shift left by 3 places, so we put LSL #3. LSL #3. So you should read this as R1 is now equal to R0 shifted across by 3, and then subtract R0. And this thing is equivalent to 7 times R0. So if we run the code again through the debugger, hopefully we'll get the same result as before. 7 lots of 13 is 91. So we'll run it and we will see what will happen. Okay. Skip ahead. So mov 13. And then do that very complicated instruction. And we do indeed get 91 in the R1 register. So this is the shortest solution, because I mean obviously you couldn't do it with zero instructions. So the best solution to this problem is a single instruction using the barrel shifter to help us do a shift and a subtraction in a single cycle.